This is another part of the great Cal Basic explanation of what I've done with the F1 evaluation platform from Microchip. As we saw before, what we've got is a couple of levels of display in this thing. We've got an LCD display, the processor, temperature gauge, etc., real-time clock, and a pot. And basically, I can press a button, I can see the time. I can see it says time because it says real-time clock here. I can see that the seconds are coming out the real-time clock, and randomly, virtually randomly, the button here, the decimal point, is flashing, and you cannot see it on that screen, but there is another display there, and it says A for AM. I can change the time, so I'll show this very quickly. If I hold the time down, I can set the time to the current time. Just change to PM, and I can just select the time. It's pretty simple. Just rolls through. This is the code. And there, the clock is running at 3:20 PM. I can look at the current temperature. The current temperature is 31. If I hold the button down, it shows me that the max and minimums are 35.5 because I actually put my finger on a moment ago, and 31. If I let it go, it will then revert back to the current temperature. If I hold it down for an extended period of time, about 10 seconds, it will actually reset the values, back the mins and max back to 0. This functionality wasn't in the original demonstrator code, but it had value when I was demonstrating it earlier on. Oh, sorry, I was using it. And now we've got a pot value in here. And this pot value is the value of, I guess, a tool is the value here. I'll just rotate that using my little tool. There we go. You can see that. So what I want to show you very quickly is in the code I've written is I've actually put a lot of support for ANSI coding. ANSI code is it's an old protocol I used to use many years ago on dumb terminals to position cursors, change font sizes, etc. And I've written some routines that you can actually use as part of the kit I'm going to post up on a forum. That's just compiling that up. It was currently at 44% and 32% program memory and RAM respectively. After I've actually just taken out that the definition, you will see that that increases up to nearly 60% and 44% respectively in terms of program memory and RAM. We got the same code, but we've actually got, as you can see now, a screen here, and that screen here shows us the state of the button and what the actual code is doing. If I push the button now, you will see that you're getting the actual state of the button. So I've actually got it held down now. If I hold it, if I let it go, you will actually see it was released, and that's a state change. This is has 4 states, the button, and that's part of the code I'll give out. So if I now hold the button down, we're looking at the temperature. I can see I've got the button down. Now, I won't see the max and mins in the same time period. It takes a little bit longer because it's all time dependent, and a lot of the time has actually been taken up now processing the RS-232. It does slow things down. There we go. It started to reset things. Quite cool. But the point here is I'm showing you some the output down the serial line. This is the pot value. We can output almost anything we like. It's pretty simple to do. There we go. We're seeing that the same values are coming on the screen. So I'm using the hardware on that, and that's a set of routines I've written, and they're pretty easy to use. So I'll just show you. The Synwrite has really messed up this screen. This screen here is a position on the screen, series of outputs. You'll have to forgive me on these positions of the indents. When I brought it onto this computer, it has made it a little mess of the display, but that's what we're not looking at that. The point here is we can see that we can actually output some quite nice debug into the PC. I will revert my code, put it back to as it was, turn off the def, recompile, and we'll be back where we were. The code will be a lot smaller, quite clearly, and that's because of strings that are actually in the display. Things like started, the version numbers, etc. We'll just compile that up and finish it up now, and it will revert it back to where we were before. Let me just see that happen, and then I'll kill this video.